Hey, so I wanted to show you how to do parallel tool calling in LangGraph. Quickly, for this video, I'm just going to run through like what parallel tool calling is, why I'm covering it this week, a couple ways to resolve it probably. Then I'm going to show a bunch of code examples of what I set up previously, which was LangGraph, just a function agent, and then LangGraph tool agent. And I'm going to do a kind of a walkthrough of the differences to get to the tool agent and significantly reduce your token usage. And then finally, I'll probably just do kind of a slow kind of walking through the actual code of how LangGraph operates and just kind of like walk through each of those nodes. So I'll tackle this in 3 chunks. I'll put in some chapters so you can see it. I'll also add the notebooks to GitHub and link to those so you can play along with those if you want to as well. So let's dive into what I'm working on here. So last week I shared a couple demos. One was basically just an agent with tools using LangChain out of the box, not using LangGraph. Um, and it operates pretty well, comes in here at 200 tokens-ish. And then I built one that was the exact same thing using LangGraph to do that, and it was significantly higher. I realized the reason was I was using function calling as opposed to tools, and that's just kind of how LangGraph has it set up, but the function calling calls the old OpenAI functionality, which is just one function at a time. And I wanted to do, an experiment to see how you would actually set up maybe a complex LangGraph structure. If you have a hierarchy of agents and you want some of them to be running in parallel, you're going to need to use these tools. So I experimented with that because I couldn't find any demos on it before. So I'll walk through that chunk in code. But before we dive into that, just an explanation of what's going on here. If we take a query like this, where is it warmest? Austin, Texas, Tokyo, or Seattle? And by how much is it warmer than the other cities? It has to do a couple of things here. So we need to figure out what the temperature is in Austin, what the temperature is in Tokyo, the temperature in Seattle. And then once we have all that, we have to figure out which is the warmest and then how much warmer it is than the others. So to do that, I set up a couple of tools. We just have a quick a weather tool, which just gives you the weather of a city. And we have a calculator, which just measures the difference, or calculates the difference between two temperatures. So it's really just two tools. It's a pretty simple example. But if we see here on the left, this is an example of if an agent's operating where it can only call one request at a time. These basically compile over time so that it makes a request for the weather in Austin and it comes back. And then it has this entire history of all of its messages that it now passes through to a new tool request and then another one. And it doesn't need any of that context for as it's advancing, but it kind of out of the box features, you're just going to be including this long message history. So along here, we can see each new message that's happening, they kind of stack, but they're stacking every time we send a request, it has to take in the entire previous request plus the new one. Oops, same thing. So this just kind of keeps going out of control. And so to go from one input to one output with the function calling, we've got 6 messages. By the time we're sending the sixth one, it's got a message history that's 12 long. So each of these starts to get incredibly long here. So one way to kind of reduce that total token usage, which was 2,000 to just complete one kind of simple query here, would be to use parallel function calling. And so this is a feature pretty much out of the box of OpenAI, some of their newer models. Um, it's just the ability to basically call multiple tools simultaneously, and it's just using its own logic to know that, oh, I can call and request 3 weather reports at the same time. They don't impact each other, so all of that can be handled. And then once we get all of those, then we start to do some calculations on it. And so if done well, it'll make all the tool requests the same. Once it has those, it'll send out kind of 2 separate queries just to understand the difference between the hottest city and the less hot cities. So it should be able to do this in 3. And the last one is just me formatting the response. So it should be able to do it with just one weather request for 3 different tools, one calculator request to go out twice the calculator, and then one formatting. And so when done effectively, it's somewhere around 200. This one actually didn't perform perfectly. We can see the agent did this correctly. It's got one chat where it does 3 weather checks, one chat where it kind of stupidly does 3 differences. It's for some reason find the difference between the 2 cooler cities, so it's not actually useful. But in the output, we do finally get that. All right, current temperature in Austin is here, warmest in Austin. This one wasn't formatting it, so the format is a little bit weird. We can see with the function calling, it has to just keep going back and forth constantly. And it actually looks like it's not even successfully logging everything in Langsmith here. And then finally with the tool calling, we can see this is the new LangGraph approach with tools, 3 weathers at once. It doesn't get the differences perfect, but even so, we've got 250 tokens there versus 2,000 with the single calls. So that's how this works. That's how, OpenAI, which most people are using, one of these newer probably GPT models anyway, it comes out of the box with those. There is also this interesting paper that I saw that proposes basically an LLM compiler to do parallel function calling. And in this, they propose basically an approach that just does the planning session. So you could, even with any model, you can now kind of like use this compiler, and they've got a GitHub repo up that you could play around with. LLM compiler, pretty cool. But it basically is, it would do a pre-step or planning step to basically figure out all of the tools to use. You could execute all of those simultaneously. So out of the box with OpenAI, but this is something that with a little bit of work, you could apply to any model that kind of has enough reasoning power. Um, so that is basically how the parallel functions work. And you can see, they're going to stack. Maybe they're even going to stack a little bit higher because it's appending kind of 3 responses to each of these. But by only sending 3, we don't have to resend the history several more times, which is basically um, really going to increase your token count rapidly. So that's one approach to shrinking the token count. There's probably going to be several others. Another significant one is, you've got to wonder if there's an easier way to kind of compact message history through an agent. It's arguable that you don't need all of these history to kind of do this correctly. You might be able to kind of condense the history. So there are going to be some ways to do it. Also, if you kind of move some of these into sub-agents, you could have an agent that retrieves all the weather, and it could do all of that without kind of, it would manage its own state, pass that message back up to the maybe an agent router or something like that. So there are different ways to approach it, but when you have a really simple structure like this, um, the parallel function calling is going to be a huge reduction for you. So a lot of different options. This is going to be the easy one that we're going to approach today. And so now we'll jump into the code here. So like I said, I put all of these in GitHub. All right, so we have these 3 notebooks. The first one is just a setup with just using their basic out-of-the-box agent, not using LangGraph. So the setup is going to be really similar. For each of these, the notebook setup is going to be the same, just kind of bringing in all of the API keys that you need. The tools are going to be the same as well here. So I set up 3 different ones. The first one is for getting weather, where it's just get the current temperature for a city in Fahrenheit, kind of say what the function actually does. So we're going to use the Open Weather Map API. And then this is what it expects as a city in the country code in order to make this request. So that's our get weather tool. Then we have the really simple calculator, which is get the difference between 2 numbers. So we can use this to just run the actual calculations since the LLMs aren't super great at math. So that's a simple tool. And those are the tools we're going to pass through to each of these. So this is the agent where we're just going to create an OpenAI tools agent and invoke it with our input. So that's the very simple approach. Once we get more complicated here with LangGraph, I'll pull up these 2 side by side so we can look at both of them. This is going to be the exact same setup. So the tools here are identical. We've got the weather and the difference, and we put these here together, and we actually have to just create a tool executor that we can call later. So the tools, let me just shrink that one out of the way, are going to be the same for both of these. So let me also get that out here. So now we set up the agent. And so this is going to look very similar for both the one on the left is going to be for calling individual functions. The one, and that's what I demoed, I think, in a previous video. And then over here, this is going to support the parallel tool calling. And so I also, this is an additional step for these is I wanted a structured response. So give us the warmest city and explain, how much warmer is it than the other cities. So those are identical. And then we're going to set up kind of the brains of the process here. This is our LLM that is really simply a helpful assistant. And we put in a placeholder to put our entire conversation history into. So we're going to initialize these the exact same way. That's all going to be the exact same. The difference starts to be right in here. So here we're going to define our functions where we bring in all of those tools that I mentioned above, and we're going to append this little response. So those are the three tools that it can use. So response is just going to be kind of one of the tools it has access to once it's ready to return the response to the human. And I named these functions, um, and then these I just named tools, even though at this point, this function actually works the same for both of those. I think it supports the tool setup the same way it supports the function setup. So that's a new change from LangChain. But when you actually create the model here, the difference is that I'm going to bind these as functions to the LLM. So, we pass in our whole input here, send it to the prompt, and that passes over to the LLM. And then I'm binding these functions right here. It's almost the exact same, but we're specifying bind tools. And so this is clearly saying this is not using the old OpenAI approach of functions, it's using their new parallel function approach, which they kind of call tools. So that's the only modification here, just in the agent setup. But then it's going to kind of cause some cascading issues down here. So we're going to make one modification to how the messages are saved in the state, and I'll walk through that in a second. Um, but first, let's talk through kind of what the actual changes are. So the nodes are going to be modified slightly. Where previously the agent was checking to see, am I finished? It would say, was there a tool call? If there wasn't, we're done. Otherwise, if the tool call existed and it was response, we're also done. Otherwise, continue and go actually call some of those tools. The difference here is that that was just always going to return in the additional quarks function call. But now in the additional quarks, we have a possible list of tool calls. We could have several of them. So really, we're just checking to see if additional quarks has anything with tool calls. But we have to check every single one of those individually. So we need to just loop through all of those tool calls here to see if any of them are named response. So that's kind of difference number one. Difference number two, we jump down to the call tool. Now the expectation over here was that we just had a message in it. We knew there was going to be one tool call, and we would just do a tool invocation with that function call name, with the function call arguments, and we would get the response here by invoking that and create a function message with the name of the tool and the response. So the first difference is down here is that we're not going to be using a function message anymore, we're using a tool message. And because there might be multiple tools, as opposed to us just running through with the one known, we have to do just a quick loop here to say, let's go through each of these tool calls individually. For each of them, we're going to do a tool invocation. That tool invocation now requires the ID as well. The function calling doesn't require the ID. Tool calling does because it might, request several and then the response need to map back to the correct one. So they always both need it when we invoke it, but we also need it in the message history for it to be able to, correctly understand the relationship between each of these. So a couple differences there, really, that we have to loop through it because we're expecting several tool calls. For each of those tool invocations, we need to set up an ID. And when we're creating the tool message, we're still passing in the content the same way, the name the same way, but we just need to call that tool call as well. The other change down here, previously we were just kind of adding always one function message through this operator that we specified in the messages. Every time we kind of return one item in an array, it would add it. It didn't seem to work, so I was just, as opposed to still using the operator, I'm just taking the messages that already existed, appending some of the new ones, and then fully overwriting it. So we're not using any operators or anything here. It's just kind of managing it ourselves. And because I'm doing that, every time we write to messages, we need to remember to do the same thing. So here we're going to be appending to the existing list of messages our newest and overwriting it. So a little bit different here of how I was setting that up. So that's the big difference. The graph is going to be entirely the same. No changes. We're still just, have an agent that's calling the model every time, or the action that calls the tool. We're always going to start with the agent. We've got the conditional edges on the agent to be whether we're continuing to call a tool or if we are ending. And then every time we run an action, we head back to the agent. So that's all the same. And then the other difference down here is when I actually, invoke this, This made so many requests that we were actually hitting the built-in or the default recursion limit. So I actually have to kind of pass in a higher recursion limit into the config so that it can actually make enough requests to complete. So it's doing so many activities there that they try to shut it down by default. So got to override it there in order for this one to work. But once they both run, they should ultimately, way out here, spit out an explanation that Austin is 35 degrees warmer. And same thing, I'll have to slide pretty far here, 35 degrees warmer in Austin, Texas than in Tokyo. So that's just using the 3.5 model. I don't know if I'm even using the latest version of the 3.5 model, 3.5 Turbo 1106. So they've gotten better. This is back from November's model, and it still works pretty well in this parallel calling. So that's a real quick overview here. You can go in and check out the notebooks in GitHub. If anyone's interested, I'll also just continue now, and we'll do kind of like a much deeper dive step by step through this and just kind of get a visualization of what the graph is actually up to. So maybe we'll kind of follow along all of our different nodes that are being called once I invoke this. If you're going to drop off, thanks for watching. Otherwise, let's dive into some debugging here. So I added some breakpoints up here that we can just inspect and see what's going on. But right away, right when I call it, if we look at our graph, we do the set entry point of agent. And so agent does the call model. So we're up here in call model, and we can look to see what it has access to. So it's got state by default, that's what we pass through, and I set messages as, remember, we were getting the entire list and we're going to be appending to it and returning. So let's look to see what our messages are so far. We just have the one human message that I passed in. Where is it warmest? That's the initial query. So if we run that, we get the response, and our response is this AI message. Let me make this a little bit bigger. And this, in the additional quarks, we'll see that it has all of the tool calls here. So the very first one, oops, has 3 tool calls, where it's calling get weather for Austin, get weather for Tokyo, get weather for Seattle. So we can already see that is going to be, if we check out what our new message history is going to be, it is the AI or the human message with the initial question, and then the AI message with all 3 of those tool calls. So let's continue and see where it takes us in the graph here. So once the model runs, that is our agent node, we have this conditional node set up. So agent now checks if it should continue. So going back up here, we're in the should continue function here. We get the last message, and this is what we're curious about. So did the last message contain any tool calls? If it didn't, we're done. But we know that our last message does contain a whole bunch of tool calls. So the next thing it checks is, did any of them have the function name response? Because at that point we know that the response is done, so we would also end in that scenario. And none of them do. They're all just checking the weather, so we continue. So going back down here, where does that take us? We've got the conditional edge. Continue takes us to action. Otherwise, if it were end, we would wrap up and exit this graph here. So we did action, and action is call tool. So that's what our node calls. And so here we are. We'll check. We should have the same last message here. Oops, I haven't. Now we have it. And so what we're going to do here, we're going to run through each of those additional Quark tool calls in our last message. So we make each of these tool calls. So let's check out what our action does as a tool invocation. Once we invoke it, we'll get the response. So that was get weather for Austin. 73 degrees, pretty nice right now. And now we create the tool message with that. So we add our response, we add the tool. So what was our action tool we just used? Was get weather. And we even have this tool call ID. So that will map back to actually seeing what our, if we go into this last message, tool calls, oops, we see that it has this call ID. So that is, we know this answer maps to this request. And so it's going to run through each of these and do that exact same process. And then we're going to append the messages. So now if we look at what our messages look like, oops, we should have the human message, the AI message, and a tool message. And for each of these tools that we go through, it's going to do that exact same process. It's going to invoke it, it's going to add it. And so we had 3 get weathers. So that should be done here. And let's look at now what our messages look like. So we should have all of those tools appended to our message history. So here we go. Initial request, the AI message, which tells you which tools to use, and then our 3 tool responses that tie back to each of those individual requests. Okay, so that would be our first round of tools is done. So when we finish here, going back to reviewing the graph, we know that every time an action is complete, we go back to the agent node, and the agent node, we know, calls the model. So here we are within call model again. We know we've got this big list of messages that includes all of our tool responses. So it's making a new request with all of those, figuring out what it needs to do, and we'll see what the response, where that's taking us. So we've got a new response. It's got just one tool call. Ideally, it would be identified that it could do all of the differences here, but it does seem to kind of keep making these as individual requests. So we know that's done. Going down to the graph, every time we finish, gosh, what were we just in? Oh, this should continue. Or sorry, that was called model. So we know that when the agent finishes, we'll do a should continue test here. So here we are up in the should continue. It'll get the last message. We just reviewed that, so we know that it does have tool calls. The tool call is not response, so we're going to get through all the way to the end, and it's going to continue. It's going to make the tool call. I don't think we probably need to go through this one in great detail, but let's just look after we append that message what it looks like now. So we have our new list of messages. We can see that this was the recent tool requested, so we just added the tool message response. So we've got the content of 35 here with our difference tool. So now that's basically our entire chain has gotten to be AI message, all the tools, AI message tool. We're going to probably go through that 2 more times here to get the difference, so we'll just kind of zoom through those. Let's just confirm that the last message here has another tool call that is difference. Okay, so we're just going to go through another difference. We're going to call the model one more time. Let's check this last message. Let's see if we're almost done. Oops, step one more. Okay, where do we go here? One more difference. Okay, so let's round through that. So it's still calling another tool again. Here we are in the call tool. Once we get that back, we know we're going to call the model. That's the agent node. We're going to invoke that. Every time we run the model, we're going to check if we should continue. We're going to see what the last message is. And I think finally this should be our end one. Okay, so we get to the response stage. So there are tool calls, so it's going to skip this. But now we've added one more check here. So do any of those contain response? And it does, so we finally end. And that got us to our very end state. So there you can see how it bounces back and forth through the nodes that we specified, how it takes those tool calls, creates the message history of each of those different tool responses or tool messages, how we modified the messages to account for this new history. So it did successfully do at least the weather through all of the parallel calling. The differences, it seemed to fail at that, so it was calling those one at a time. So in the end, I think if we go over to our demos and see where we ended up, we've got the initial chat, we've got 3 get weathers in a row. We now have an output where it's trying to get the difference. It gets a difference. It figures out one more time with that entire history that it needs another difference. Then it needs one more difference. So it now calculated that even though this is a bad decision, it shouldn't be checking the difference between the two cooler cities. I didn't ask it that. And then it finally, once it has all that information, makes the final response with the warmest city and explanation. And if we look, we're at 255 tokens there, which is pretty good, especially if we compare it to the 2000, which we go through individual function calling. So yeah, that's a quick walkthrough of basically just the behind the scenes of what the graph is up to, how to make those parallel calls. I hope that was helpful. All of these are going to be, I'll put it in GitHub so you can go play with them. Really, just thanks for watching. Let me know if you have any questions or thoughts. Thanks.